To solve a system that has 3 equations and 3 variables, our goal is to eliminate one of the variables from 2 of the equations. So the first thing I'm going to do is I'm going to label it 1, 2, and 3. Those are my equations. My first, my second, my third. And my goal is going to be to eliminate the same variable from 2 of those. So I just need to pick 2 of the equations, group them together, and eliminate a variable. So I'm going to eliminate my first equation, or I'm going to group actually my first equation and my third equation. So when I group these together, my first and third, this is what I'll get. So there is a grouping, a system of my first and my third. And I need to eliminate a variable from this system. And it looks like the x's are going to be the easiest to eliminate. So I'm going to multiply in order to eliminate this, and this part should be practiced. To eliminate the x's, I'm going to need this bottom equation. I'm going to need the coefficient in front of the x to be a minus 4. It's already a minus 1, so let's multiply the whole thing times 4. What I'll get, up top, the system won't change. But down below, when I multiply the whole thing times a 4, I'll get a minus 4x plus 8y minus 20z equal to 17 times 4 is 68. So I'm eliminating the x's from this 1 and 3. So when I add down, the x's will cancel. I'll be left with 5y. This will be a minus 19z equal to 58. And I'm going to label this as my new number 1. That's what I'm going to call this. New number 1. I used 1 and 3, and I eliminated the x's from that. So now I want to do, since I used 1 and 3, I need to group 2 other equations together. I could use 1 and 2, I could use 2 and 3, and actually that's my only option. I could use 1 and 2 and 2 and 3, but I'm going to have to eliminate the same variable. So you have a decision if you want to group these 2 together and eliminate the x's, or if you want to group these 2 together to eliminate the x's. And actually it doesn't look like it's going to be too bad there for either one. So I'm going to group the second and the third equation together. And let's see what we get. So when you group the second and the third, you'll get 2x plus y plus 3z equal to 0. And I'm going to need to eliminate the x's here, right? So I need to eliminate these x's. If this is a 2, this needs to be this number in front needs to be a negative 2. So I'm actually going to multiply this whole thing times 2. So I'm going to multiply that whole thing times 2. And I'm going to put that as my number 3 equation. So when I do that, I get a minus 2x. And 2y times 2 is a plus 4y. Minus 5 times 2 is a minus 10z. And 17 times 2, this is going to be equal to 34. And now, when I add down, my x's will cancel. I'll be left with 5y. 3z minus 10z, this is a minus 7z. Let me erase that and write it a little bit clearer. This is a 7z. And 0 plus 34, that's a 34. And I'm going to label this my new number 2. My new number 2. So I used my third equation and I grouped it together. I separated it, so I grouped it with the first equation over here, grouped it with the second equation over here, and I eliminated the one variable. And it has to be the same variable. It wouldn't make sense to eliminate the x's over here and then come over here and eliminate the y's. So you have your choice. You can group 1 and 3 together, and 2 and 3, or you could do 1 and 2 and 2 and 3. I mean, there are different ways that you can do this, but I decided to group 1 and 3 and 2 and 3 together. So what I'm going to do now is I'm going to group my new number 1 and new number 2 together. So my new number 1 was 5y minus 19z equal to 58. And my new number 2, or excuse me, this should say new number 2, not new number 3. So if I've been saying new number, oh, there it goes. If I've been saying new number 3 or 2, I'm sorry, but this should say new number 2. That should be a number 2. All right, so my new number 2 will be 5y minus 7z equal to 34. And I guess it doesn't really matter if it's new number 2, new number 3. The point is we eliminated one of the variables from that. Now on the next page, I'm going to solve this system. So let's solve that now. Okay, so on this page, I have my new number 1 and my new number 2 in this system. And my goal is to solve this. And I can do this because I have 2 unknowns and I have 2 equations. So usually we're used to seeing x and y, but if we have a y and a z, that's fine. So just to recap, I eliminated one of the variables from 2 of the equations. I got my new number 1 and my new number 2, and now I'm going to, without that variable, that extra x, I'm going to solve this. So you can solve this using any method you'd like, but it looks like we can use the elimination method. Here's a 5y, here's a 5y. I can subtract these 2 equations, right? I can subtract these, and when I do that, the y's will cancel. I'll have negative 19 minus 7z. So that's going to turn into a plus 7z because a negative 19 minus negative 7 becomes a positive 7. This will be a negative 12z. And on the right-hand side, 58 minus 34, that's 24. So that worked out pretty nice because now I can just divide by negative 12. And I see that my z is equal to negative 2. That's great. I got one of my variables. Z is equal to negative 2. So now let's step back. Now that we know z, we can use z, plug it into one of these equations, and figure out what y is. So I'm going to plug this into my second equation. So I'm going to solve for y. 5y minus 7 times negative 2 equal to 34. I'm plugging negative 2 in for z. I get 5y plus 14 equal to 34. This looks like it'll turn out well as well because I'm going to subtract 14, not 34. Subtract 14 from both sides. I get a 5y equal to 20. Divide by 5. I'm going to get y equal to 4. So once I eliminated the x's, I had a nice system that I can solve, and I did that. I got my z equal to negative 2, got my y equal to 4. The only thing that's missing is my x. So now that I have 2 of these things solved for, I have my z, I have my y, I'm going to choose one of these equations, plug in z and y, and solve for x. So I'm going to plug this into this middle equation. I like that because this side's 0 and everything else over here, these coefficients are positive. So I'm going to plug z and y into this second equation. So I'll get 2x. Let me erase that. We'll get 2x plus y, so this is 4, plus 3 times z. Z is negative 2, equal to 0. So we'll get 2x plus 4 minus 6 equal to 0. This is going to turn out nice. 2x minus 2 equal to 0. I can add a 2 to both sides. 2x is equal to 2. Divide by 2. X is going to be equal to 1. So I eliminated the x's to get a system that I can solve for the z and the y. But then once I got those, I need to make sure to go back to an original equation, plug in my z and my y, and solve for that x. Remember to write your solution as an ordered pair. So my x is 1. My y is 4. My z is negative 2. Just to summarize and just to make a final point here, at the very beginning I selected my first equation and my third equation and separated those, and then I used my second and third. And my goal was to eliminate the x's. I just want to say again that it doesn't matter which two equations you group together or which variable you eliminate. I could have grouped the first two and the second two together and eliminated the z's first, or I could have eliminated the y's. It doesn't matter as long as you eliminate one and the same. It has to be the same variable from one of the equations or two of the equations. You'll get your new number 1 or your new number 2, maybe you'll get your new number 3, but you're eliminating the same variable from two separate equations. And that allows us to get a system that we can solve and then use backward substitution, plug those in, and solve for x.